So hey everyone, let's continue from where I left, which was composition, that is classification of matters. Today I'll cover nature of matter. Just to recap, okay, nature of matter is also done. So I think the next one, I don't know. So in the nature, matter is defined as something that has mass and occupies space. Then they are further classified into solid, liquid, gas. In solid, the structure is rigid and well defined, volume is defined, but in case uh, liquid, the volume is definite, but there is no definite shape. And in case of gases, neither volume nor shape is definite. So you can convert one form to another either by heating or cooling. So this diagram over here explains what chemistry is all about. You have elements, so you study the composition, structure, property, and interact and how those elements interact with other elements. So this was slightly tricky part, which is classification of matter. So as you know, matter is something that um, I can write somewhere over here. Anything that occupies space and has mass. So now they are divided into two types, mixture and pure substance. So in case of mixture, they can have different type of particles in it. So they are called components of a mixture. Now mixture is again further classified into two types, homogeneous and heterogeneous. So in heterogeneous mixture, the components are different, whereas in homogeneous, the no, not the components, but how those components are distributed within a mixture. um, Homogeneous, they are uniformly distributed, and composition is uniform. So over here I added few points. Composition is uniform means that if you take a sample from any part of the mixture, it would have exact same ratio of properties. And then under pure substance, you got elements, compound, and then elements are of two type: atoms, molecules. So these are some side notes which I added by asking Claude. So just in case if I have to revisit any concept. So now I'm gonna start from it's done properties of matters and their measurement. So the chapter is going to start from laws of chemical equations. I think laws of chemical combination. And before this, they are just teaching you basic mathematics and how you measure various quantities. So every substance has unique or characteristic properties. Now these properties are of two types: physical and chemical. Within physical you have color, order, melting point. Chemical is their reactivity, composition, things like that. Physical properties can be measured without changing the identity of the composition of the substance. That is, there is no chemical reaction. You can just observe uh, their melting point and things like that. Then you have chemical properties. Requires a chemical change to occur. Does not require occurrence of chemical, and these include acidity or basicity, combustibility. In the following section, we we'll learn about the measurement of physical properties. Measurement of physical properties, quantitative measurement of property. So, like, how do you measure something? How do you quantify it? Quantify means assign a number so that you can measure, you can do mathematical calculations on it. So, starting from, okay, your properties of matter. uh, then you have two type, physical and then chemical. So within physical, the identity or the composition, identity identity or the composition of the element doesn't changes. And what are some physical properties like color, odor, uh, melting point, I think boiling point, um, whereas in chemical properties a chemical change occur. But in case of chemical, a chemical change occurs, the composition of the element changes. And the example of a chemical properties are characteristic reaction of different substance. Okay. uh, so what are example? It's their reaction with other elements. Measurement of physical properties. So quantitative measurement of properties is required for scientific investigation. Many properties of matter such as length, area, volume, etc. are quantitative in nature, and any quantitative observation or measurement is represented by a number followed by a unit. So this basically means, when you're quantifying a quantifying anything, it could be length, weight, speed. So you write a number and then the unit. So for example, length of a room can be represented in 6 meters. So there are two type of system, English and metric, uh, where will be used are used in different part of the world. The metric system was organized in France in late 18th century, was more convenient based on the decimal system. Later, need for a common standard system was felt by scientists. So then they developed the SI system. So the international SI system. You can learn more about English and metric system. There's also a lot of memes regarding uh, the measurements that are used in United States. They don't use SI units over there. They use miles, pound. Uh, I don't know why, even though metric is way more convenient. So I can say measurement system. Measurement system are of two types, metric, and then we got English. So the International System of Units in France, Les Systèmes International, as SI unit, was established in the 11th General Conference on Weights and Measurement. They're just talking about the history and the organization behind who maintains SI unit, things like that. Has 7 base unit. Okay, these units pertain in 7 functions. So the SI system has 7 base units. What I assume is that using these 7 base unit, you can uh, come up with other units, for example, kilojoule. That's my assumption. I'm not sure about it. So there's 7 base units. These units pertain to 7 fundamental. The other physical quantities such as speed can be derived from these quantities. Yeah. See, 7 base unit and other properties such as density, speed can be derived from these base units. Properties. Uh, Instead of writing this table, I can just copy and paste it. So these 7 base units are length, which is in meters, mass in kilogram, time in second, electric current in ampere, temperature in Kelvin, amount of substance in mole, luminosity in candela, CD. The definition of the SI base units are given. The system allows the user of prefix to indicate the multiple or submultiples. So they are telling how because let's just say that if you are defining 1 meter, so somebody would have said, okay, this much distance should be considered 1 meter. So how did they come up with? So this is what this table is all about. I actually remember reading about time. So this one is some frequency of uh, cesium atom, and also uh, mm, the atomic clocks are also built using this element cesium. So currently there's I think 3 atomic clocks all over the world. One is in Switzerland. So the time that you see in online, for example, in your Windows operating system or things like that, are powered by those atomic uh, clocks. They're extremely accurate. You can obviously go through it. I'm not going to go in too much detail. Maybe if I have time, then um, I'll learn more about it. So what I can do in meantime, I can Just copy this and I'll just write a note, study as a side note somewhere over here. I'll just say study more about these if I have time. But first, my goal is to cover this chapter, the numericals and problems and things like that. And then we have the prefix used in SI systems. I would have never thought that this 10 to the power minus 21 would be a part of my everyday life. Right now I'm living with my parents, so I don't use Zepto uh, since I'm here for a couple of months. But once again I go back to Bangalore, it'll be again Zepto. Prefixes, and I'll also paste this over somewhere here. So first they're talking about mass and weight. Uh, Mass of a substance is the amount of matter present in it, while its weight is the force. The mass of a substance is constant, whereas weight can vary. You should be careful with these terms. The SI unit of mass is kg, but since you don't use 1 kilo of a chemical substance, so they are often expressed in grams. This is used in laboratories. Okay, so over here I will write a table and weight. Mass of a substance is the amount of matter present in it, and second is mass is constant, whereas weight is the force exerted by gravity on an object, and weight varies from place to place. So the SI unit of mass is kg, and 1 kg equal to 1000 grams. So next is volume, is the amount of space occupied by a substance, often expressed in length to the power 3. So length SI unit is meter, so it's meter cube. Smaller volumes are used, hence expressed in centimeter cube or decimeter cube. A common unit, liter, which is not the SI unit, is used to measurement volume. So 1 liter is equal to 1000 ml and 1000. So let's understand this diagram. Or maybe what I can do, I'll ask Claude to explain this. Because in chemical reactions, volume is also expressed in liters. Probably they give you the amount of liters, so you need to convert it into volume or volume to liter, vice versa. So this is important to understand. It is the amount of space occupied by a substance. The unit is length to the power 3. So the SI unit is meter cube. Wait, I'll copy this and give this to Claude. Why volume? Why what I don't understand is why liters is explained under volume concept. Is that volume can be converted to liters and vice versa? Exactly right. Liter is included here because it's a unit of volume. The textbook is showing that volume can be expressed in multiple units and liters happen to be one. Okay, so you can volume can also be expressed in liters. Liters. That is, you have volume. Volume can be converted to into liters. All these measurements have exact same volume, just SI derived unit, SI derived unit. So I'll say give me some simple problems to understand uh, volumes and liters. Okay, so here starting simple, convert 5 liters to into, so this will be 5 times 1000, 300 milliliters into liter. 3 liters, okay, 2 decimeter into centimeter cube. So typically what I did back then, I would convert everything to SI unit, and then from SI unit I would go to any other unit that they had asked. Convert 5000 base conversion using the cube idea. A cube has side of 10 centimeter. What is the volume? कुछ ज़्यादा ही आंसर क्वेश्चंस पूछ लिए इससे. सच में मेरा प्रॉब्लम सॉल्व करने का मन नहीं कर रहा है। ठीक है चलो करते हैं सॉल्व। ये है क्वेश्चंस। Some problems to understand volume and liters. So इसका आंसर होगा 5000 milliliters. This one is 3 liters. Convert to decimeter cube into centimeter cube. तो इसका मैं कैसे करूँगा? Wait, let me look for some hint. Okay, volume यहाँ पे दिया हुआ है 1000 centimeter cube equal to 1 decimeter cube. तो मेरे पास x सेंटीमीटर क्यूब शुड बी इक्वल टू 2 डेसीमीटर क्यूब. तो मेरा x की वैल्यू आ जाएगी 2 times 1000 which is 2000 centimeter cube I guess. Let's see. देखते हैं क्लॉड से पूछते हैं क्या आंसर होगा. 2000 centimeter cube. Okay, so 1000 centimeter cube is equal to 1 liter. So 5000 centimeter cube equal to x liter. तो x की वैल्यू आ जाएगी 5000 divided by 1000 which is 5 liters. And 0.5 liters into centimeter cube. So 1 liter is equal to 1000 centimeter cubes. So 0.5 liter is equal to x centimeter cube. तो x की वैल्यू आ जाएगी 0.5 times 1000 which is 5 times 500, 5 times 100 which is 500 centimeter cube. 500 centimeter cube. तो क्लॉड से पूछते हैं these are my answers. Are these correct? All 5 are correct. Let's go. Okay, so I think ये तो मेरे को समझ में आ गया. ये बोल रहे हैं 1000 सेंटीमीटर क्यूब अगर आपके पास है तो इट्स इक्वल टू 1 डेसीमीटर क्यूब. ये कन्वर्जन के लिए काम आएगा बट ये विजुअलाइजेशन मेरे को समझ में नहीं आ रहा है. अच्छा हमारे पास एक क्यूब है आई थिंक 1 सेंटीमीटर क्यूब. आई थिंक डेसीमीटर बड़ा होता है सेंटीमीटर क्यूब बड़ा होता है. तो क्लॉड से पूछते हैं ये सब क्या है. दिस explain these part in the diagram. Uh, the circle part of the diagram is showing the scale reference. For big cube, it's telling you how the cube is built up from tiny cube. The two labeled one 10 centimeter equal to 1 decimeter. Okay, so I think decimeter बड़ा है. The bottom edge of the cube is labeled 10 centimeter equal to, okay, so यहाँ पे 10 centimeter which is equal to 1 decimeter और ये है 1 centimeter. This showing that the big cube side is 10 centimeter long and the 10 centimeter is 1. This is just restarting unit. The small trick mark 1 centimeter shown that the big cube edge is divided into 10 smaller segments. Okay, it's made up of tiny. The tiny separate cube on the right, 1 centimeter cube equal to 1 millimeter. So that tiny cube is one single small unit cube next to the big circle to show what one. Okay, so what is what 1 centimeter cube equal to 1. Connecting the two parts of the figure, the big cube 10 centimeter side cube is equal to 1000 to 1 centimeter cubes stacked together. So 1000 centimeter cube is equal to 1000 mm which is equal to 1 decimeter. Okay. So ये ऊपर से फिर आ गया हमारे पास. You have one cube 1 centimeter. So if there are 10, that is 1 decimeter. So since this is volume, you have width, length and height, so you multiply 10 3 times, so you get 10 centimeter cube which is equal to 10 millimeter. अच्छा मेरे को समझ में आ गया ये क्या करना. So यहाँ पे लिख देता हूँ this diagram means this diagram is explaining 1000 centimeter cube is equal to 1000 milliliter and which is equal to 1 decimeter cube which is equal to 1 liter. So since it is volume, we have height times width times length. तो इसीलिए you take 1 centimeter cube 10 times, so you get 10 star 10 star 10 which is equal to centimeter cube. So here एक arrow बना देता हूँ, curve arrow. I think इस arrow को उधर से लेके जाते तो ज़्यादा सेंस बनेगा. और दूसरा ही बना देते हैं. So in laboratory, volume of liquids or solution can be measured by graduated cylinder, burette, pipette, volumetric flasks. Prepare a known volume of a solution. ठीक है भाई. इसमें से मैंने एक भी नहीं तोड़ा था. एक लड़की थी, उसने पिपेट तोड़ दिया था और उसने जल्दी से जाके डस्टबिन में फेंक दिया, तो किसी को पता नहीं लगा. डेंसिटी बाकी सब मैं नेक्स्ट वीडियो में बात करूँगा. So anyways, thank you so much for watching. GG.